Welcome back, friends. So, in the previous class, we have discussed regarding your PROMs, EPROMs, and ROMs, and all those things. So, I'll just give you a glimpse of the previous class. So, we had started with your ROMs, right? Then we move ahead with what actually is ROM, how it is different from SRAM and DRAM, and we saw n number of things in the first class. Next, we move ahead and we started with various variants of your ROMs. We came across your programmable read-only memory, which is PROM. Then we came across EPROM. Then we saw the difference between your ROM and EPROM. What could be the difference between ROM and EPROM? Next, we moved ahead and we tried to discuss your EEPROM, that is electrically erasable programmable read-only memory. So till here we have reached, friends. We have tried to bring out the differences between your PROM, EPROM and EEPROM. Okay. Now, moving ahead with all these things, the next very important topic we have is your flash memory. So today we'll be covering this flash memory and the various aspects of flash memory. Now, what actually is this flash memory then? You might have come across this flash memory in your real life as well a number of times. If you can just pause for a second the video and try to guess what actually is flash memory. Have I used it? What could be various memories? Now, before moving ahead, friends, I would like to ask a simple question which you have to answer on yourself by just pausing the video. What are the different memories you have used in your real life? What are the different memories you have used in your life? Right? So you can just pause for a second and try to do a learning on it, or try to debug your memory. What are the different memories? Now, I'll tell you what could be the different memories. All of us use your systems, I guess, laptops. Yeah. Then, does it contains the memory? Yes, it contains. Now, all of you use your cell phones, I guess, right? Does it contains the memory? Yes, it contains. Now, all of you might have used your pen drives, right? Does it contains memory, pen drive? Yes, it contains. Right? So these are my different types of memories. Now, an assignment for you guys is, what you need to do is, whatever the memories you have come across, try to categorize them. Try to categorize them into your primary memory, secondary memory, and all those things. Primary memory, secondary memory has been already covered in the previous lectures by Niranjan sir, right? By my colleague. And you just try to categorize whatever the memories you have come across into those categories. I have taken the name as well. So try to do this small exercise, friends. It would be very beneficial for you. Next, moving ahead, what is flash memory? Now, this flash memory has the structure which is very similar to your EEPROM, but it has some advantages. When we speak of flash memory, it has some major advantages as compared to your EEPROM. Now, when we speak of a flash chip, what would happen with a flash chip is, we can read the contents of a single cell. We can read all the contents of the single cell, but writing is done for entire block of cells. Remember this, friends. When you read, you will be reading a single cell, but when you write, you will be writing for the block of cells, not a single cell, right? So this is very important. So another very major thing here is, before writing, the previous contents of that blocks will be erased. Okay, friends. So we're discussing how the reading and writing is done. Okay. Now, when you do the writing, what I told you, that all the previous contents of that block would be erased. Right? That means you cannot rewrite n number of times. That is, if I write some data, you can rewrite n number of times, but when you rewrite, all the previous data would be lost. Now, another major thing is, all your flash devices have higher density, which leads to low cost per bit and larger capacity. So since it has a higher density, you can see here, since it has a greater density, then using that greater density, the advantage of this greater density is it will be giving you less cost and it will be also giving you larger capacity. So this could be easily obtained. Now, why this is important? All our flash drives have higher density, right? All our flash drives have higher density. Using that, we will be having n number of advantages. So we'll just go through those advantages now. Okay. One advantage is power consumption is very low. Whatever the power consumption of your flash memory is there, that is very low. Since your power consumption is very low, we can use this flash memory even with the battery driven. That is, even with the battery, we can use the flash memory. Now, I guess you might be getting a small idea, where is my flash memory used? Which is your battery driven device? Which are the battery driven devices we have? The simple thing, we have our handsets, mobile phones, right? We have our laptops. All these, what they are? They are battery driven. Once the battery drains, again we need to charge them. So what could be the memory they have? They have flash memory, right? Your mobile phones, laptops, they have flash memory. Why? Because they have greater density. What greater density is giving you? Higher capacity. And as it has higher capacity, what is happening there? It is making your power consumption low. Once the power consumption becomes low, what would happen? The less battery is eaten up. Therefore, if I want less battery to be eaten up, my device or my application will try to use your flash memory. Okay friends, so this is one thing. Another major advantage, one very major advantage which we were not having this in your earlier ROMs, is that this flash memory requires a single supply voltage. All the flash memory will require a single supply voltage and they consume, as we were speaking just now, a very less power. So since we have single supply voltage, there is no need to vary the voltage every time. That's why we will be getting more power capacity, right? So whatever the flash cell we have, again it is based on a single transistor. Okay, so it is each flash cell is again built using a floating gate MOS transistor, which would look something like this. So I'll just try to draw it. Please pardon me for the not so clear diagram, because it becomes difficult to draw. Okay, so this is your transistor. This is a floating gate MOS transistor. Now what is floating gate MOS? Please go back to your analog electronics, try to understand it so that it would be more clear for you. Okay, so this floating gate transistor is different from the earlier transistors what we had. What is the one small change here? Here you can see here in between I had drawn a dielectric material. This is called as dielectric material. Okay, so it's not clear, so I am erasing it. You can just I'll just make it with a small, I'll just show you with a small, okay, D is nothing but your dielectric material. Now how are the connections, friends? Connections you already know. These connections are, you already know it, we are well versed with these things. What are the connections we have here? This is nothing but your word line, this is nothing but your bit line, right? And to the other end, what we had here earlier, we had a switch. But now what we have? We have a capacitor. So we'll be putting a capacitor here. Then from this capacitor, we'll be drawing it to the ground. Okay. So this is how your flash memory looks. Small change is what, friends? Whatever the transistor we have used. This transistor, whatever you are using, that is different from all your earlier ROM cells. All the earlier ROM cells had a different transistor, but this flash memory has a different transistor. Now, why is this dielectric material required? See, Since we have a dielectric material, the current flows from source to drain when a sufficient negative charge is placed. Whenever the negative charge is placed on that dielectric material, then the current starts to flow. So this prevents the current through the word line. So whatever the dielectric material is there, that is preventing the current through the word line. Thereby we will be getting a logic 0. Thereby we will be getting a logic 0 when we do this. Okay. Now, what will happen when the dielectric material is not charged? Then the current will flow from the bit line to the word line. From the bit line and the word line, and we will get a logic 1. So please try to understand, friends. We are interested in two logics. One is logic 0 and another one is logic 1. When do we get the logic 0? When the dielectric material is placed with a negative charge. When I place a negative charge on this dielectric material, right? When I place a negative charge on this, what would happen now? The current will not flow in your word line. There will be no current in this word line. Thereby, what you get? You get a 0. Is that clear? Now, when the dielectric material is charged, that means when you pass a positive on this dielectric material, then what would happen? The current flows from the word line to the bit line like this. Please follow it. Then what you get? You get a logic 1. You get a logic 1. So this is how, friends, it is happening. So I hope so somewhat you are understanding. If you have any doubts, please don't hesitate to ask me. Okay. Now, what is another major advantage of this? So I hope so. Shall I remove this diagram? I hope so. The diagram is clear. The what transistor we are using. Okay. So I'll just clear it. Now, what could be the advantages of this then? What could be the advantages? Simple, friends. Major advantage is what? It is having less power. Since it is having less power, what are the major things we just now discussed? It could be used wherein the devices are battery driven. What are those? Your cell phones, digital cameras, MP3 players, etc. Okay. Now, how this flash memory is used? To give you some example, you might have seen your palm tops and as well as cell phones. In these devices, flash memory is used to hold the software which is required to operate the equipment. Now, which is that software, friends? Shall I repeat it? In your cell phones, flash memory is used to store the software. Which will run the cell phone. What is that software, friends? Android. Say for example, you are using an Android cell phone. Then what is the software we have? Which is running the equipment, which is running the cell phone? Android. If you are using an Apple, it is some iOS or something like that, right? Now, what is this Android, friends? This Android is nothing but your operating system. Android is nothing but your operating system. So, what your flash memory does in your cell phones, then it will be holding the operating system. Okay. Now, this is one thing. Another major advantage here is, or you can say, you can take it as per your convenience, whatever I am trying to speak it, because sometimes it becomes an advantage and sometimes it becomes a disadvantage. In flash memory, a large block of memory can be erased at once. Now, friends, just now I had given an example: A to B column, A to C column, and A to Z column. Now, this could act like a trade-off again. Sometimes erasing everything at a time could be a blessing to us. Sometimes it could turn up as a curse. That's why I told you it can be used as per your convenience. So what is happening in your flash memory? A large block of memory can be erased at once, which was not possible in your EEPROM. In your EEPROM, what we used to do, each byte was erased individually. Okay, friends. So see here, what is happening now, friends? In your flash memory, what we are doing? We can erase at a time. We can erase all the data at time, right? But in your EEPROM, what happened? In your EEPROM, what happened? It was not possible. Here we need to erase each bit or each byte, you can say. We need to erase each byte. So I hope this first point is clear, friends. This first point is clear. Okay. Next point. Coming to size. The flash memory chip size is the major contributor to the cost of the device. That's why many designers have developed many architecture for flash memories. That means if the size becomes less, then it would be helpful. So therefore we have n number of architectures coming like NOR architecture, NAND architecture, AND architecture, and so on. So when we have different styles of architecture, what would happen then? Then we can easily categorize them or easily choose whichever is required for my advantage. Okay. Now this is another thing, friends. Now going ahead, this flash, whatever we are studying till now, it has flash memory. It has various variants. Like say for example, it has flash cell. One variant is flash cell. Other variant is it has flash card. Right? Another variant is it has flash drives as well. Okay, friends. So these are my three variants of my flash memory. The first variant, the second variant, and the third variant. So we will be studying or dealing with this in detail again. So remember, friends, flash memory can be categorized into three types. One is flash cell, flash card, and flash drives. Whatever we tried to discuss till now was nothing but regarding your flash cell. Cell is nothing but what now? How a cell is formed? Using the transistor. That's what we have discussed. Using the transistor. So we have discussed that just now. So is that clear? So flash cell is clear, friends. Flash cell is clear. In the next class, we'll try to check upon your flash card and flash drives. Is that okay? I hope I am clear. Okay, friends. So yeah. So this is all regarding your flash memory for today's class. Again in the next class, we'll try to check upon various things of your flash memory. For now, I'm going to finish my class here only. We'll again meet in the next class. So if you have, please go through this class very carefully because I have discussed the structure of your flash memory. That is flash cell structure. We discussed the flash cell. That's why please go through it more clearly. If you have any doubts, please don't hesitate to ask. You can call me or WhatsApp. Thank you for watching. We'll again meet in the next class.